the channel. Another day of a hard question. 726 number of atoms, and then so we're given a formula of the chemical formula, and then we want to return the count of each atom. So let's say we're given H2O, we want to return H2, and then 0. And then, for example, the parenthesis for like OH and then 2 means this 2 will be assigned to the O. So you have 2O and then 2H, and then you want to return it in the sorted number as a string, where it's sorted by their first name and then followed by its count. So if the count is more than 1, we want to put how many it is, but if less than 1, in this case, equals to 1, exactly 1, and then you want to put just the element itself. And then noticing that if something like magnesium will be Mg, so the second G will be a lowercase, and then this means the element is 2 characters. Let's dive into some understanding. So I can't draw in Google Slides on my laptop, so I'm using PowerPoint today. So the first thing is we will think about having a stack because it's parentheses, and then we've been doing stack problems recently. So when we come to magnesium right here, we want to append it to the end of the stack, and then we set this is magnesium. And then when we see a parenthesis, opening parenthesis, we know that we need a map here. So we need a map to store how many elements in this parenthesis. So we can append a new map right here, and then we're putting O and H into it. And then by the end, we want to check the multiplier. So the multiplier will be 2. So when we end of this the closing parenthesis, then we want to pop the element out, which is the current one. So we want to pop this out. So we get 0. Oh, O and H. So we get 0. And then we'll get 2. So we'll make this to be 2O and 2H. And then we'll look at this magnesium again, and then we will see the final answer will be 1 magnesium, 2 oxygen, and 2 hydrogen. So look at the other case. We now will have a stack again, and then we'll first put K4 into it. And then when we see another opening parenthesis here, we know we need another stack right here. So we'll put O into it and N into it. And then we see another parenthesis, so we need another stack right here, right? So this will be 1s, 3 0, 3 oxygen. Oh, oh my gosh. Okay, and then we closing this. When we close this, we pop this out. We pop this out to be S1 O3, and then we want to multiply each of them by 2, right? Multiply each of them by 2. And then when we're done, we want to look at the stack. We don't want to pop this out, right? Because we want this to be still in the stack because we haven't seen the closing parenthesis of this. So we want to add whatever we have and putting them into this. And then when we see another closing parenthesis right here, should use the different color. A parenthesis right here, we know that we need to pop this out. So we're popping this out, and then we add multiply by 2 for everything that we have in this element plus this, right? Everything is here. And then lastly, we add them to the last one we have in the stack. All right, so just dive into the code. So first we need a stack, and then for each of the elements we have, we want them to be a dictionary, so it's a map. So in Python we can use this, and then since we want to going through each of the index, in the formula, and then we will be changing index sometimes. So instead of using a for loop, I will use a while loop. So I will see index to be starting at 0, and then go all the way up to the length of formula. So as we see, there will be 3 cases. One is it's just the element itself, and then the open parenthesis, and then the closing parenthesis. So let's start with open parenthesis. So if this is equals to open parenthesis, we want to append a new stack. So a new map in the stack, right? So dictionary int. And then we'll increment by 1 because we know that we don't actually want to deal with the parentheses. When we see open parentheses, we just want a new map on the stack, and then want to move on to find the actual element. Right? In another case, if it is a closing parenthesis, and then as we said, we need to pop that up, the current map. Let's look at this when we look at this thing for the first time, right? When we see a closing parenthesis for the first time, we want to pop this map out because we're done with this inner parenthesis or inner map. So we can say this to be stack.pop for the current one. And then we'll come back to this case later. So else we will have element. So we can say the current atom, because they're using atom in this question, will equals to formula at I. And then we can increment index by 1, and then we'll check the next index. So while I is less than the length of the formula, so we want to make sure that we not getting over out of bound, and then this element is also a lowercase. So it means that, let's say the case of mg, so g is lowercase, so we want this to be a whole element, right? So we set the current atom plus equals to formula at I. And then we want to count how many times it has, right? So I will say count to be a string. Now it is an empty string, right? And then while I is less than, again, because we increment the, I'm missing an increment. So want to increment the I after we get the atom done. So we want to go to the next element right here and see what's the count. So if I is again less than the length of formula, and that is a digit. So in Python, you can just say it's digit, and then we can add the count by the character right there. Why are we using while loop is because in the constraint it doesn't say that the element can only be from 1 to 9 or 2 to 9. So it could be 12 elements or 20 or whatsoever. So in this case, we just do a while loop to get all the multiplier or the count of it. So if count, so if we know that the count is empty, and then we can set stack -1 means the uppermost on the stack of this current atom plus equals 1. Otherwise, we can add by how many times it is, right? So otherwise, the count of this current atom will be equals to, because this is a string, right? The count is a string, so I'm going to convert it to integer. Okay, so now we want to come back to the case where it's closing parenthesis. So when closing parenthesis, we want to pop this out, and then we also want the previous one, which is, so now since we pop this out, this will be stack -1, because this term is now on the, this one is now on top of the stack, right? So when we pop this out, we can plus equals 1. So we are looking for how many times we need to multiply by elements in this map. So we got this, and then now we want to see the count of the multiplier, right? So we can say multiplier. Again, it's exactly like the count down there. And then while I less than, I think I can just copy this part. Yep, but change this to be multiplier. Right, so we want to see how many times we want to multiply the elements inside this map, right? And then we increment until we find the digit thing. And then let's say we said if multiplier means the multiplier is not empty, we convert this to be an integer. So for every atom in the current map, so it's like this. So for every element in the map, so now we have S and O, right? So for every element in the stack, we want to multiply it. Okay, I can just do this. Multiply it by the multiplier. And then now we know that this one has been done. So we want to add them to the outer map, which is the one on top of the stack right now. So we can say for atom in current map, we already updated the current map. So we already updated current map, which now S is 2 and then O is 6. 3 times 2. Right. So we add that to the map that is on top of the stack right now. Okay, this question is kind of long. All right. So far we finished all 3 cases. So now we will go on and handling the output. So when we come to the output, we can define a final map. I want to make sure that I am in the correct indentation. Right. Okay. We can say the final map equals to a dictionary, and then we sort that. Because now we only have one thing on the stack right now, because sandwich keep popping out when we're done. So there's only one element left. So we want this to be the stack 0, and then we want to sort them by the items. Right? And then we want the result string. So for all the atom in the final map, because it's now sorted, and then we can add the atom first into the answer, and then if this is 1, we don't want to print it, right? So we only print it when it's greater than 1. So the final map, the value of the atom is greater than 1, and then we plus equals, make it to be a string of the value, and then at the end we return the result. Wow, 50 line of code. Let's say if we run this, default, oops, good cache. Oh, cannot access answer. Oh, because I said result, but then I put answer here. Okay. Can access local multiplier. I think there will be some misspelling right here. Multiplier. Okay. Okay, so it passes the given test cases, and then we'll see if we run this, submit this. and then we'll get oh, it's not bad, and then we'll see the, oh, I cannot use it anymore. So this one is actually highly referred to the editorial, the we stack right here, and then I just trying to explain it using my code, and then using easier way to make people understand. So the time complexity will be of n squared, and then the space complexity will be of n. I hope this is helpful. This is a hard question, so it's okay if you don't get it in the first place. See you all tomorrow.